Hi everyone, my name is Julie Cosmano. Welcome to Past BI Virtual Chapter. I'd like to thank Pragmatic Works for sponsoring our session today. And I have a couple of announcements from the community and from BI Virtual Chapter. So we do have a YouTube channel that you can watch free learning, from our past sessions. So check it out. And there are upcoming SQL Saturday events. We actually have quite a lot of them around North America as well as international events, including one near me, which is in Melbourne on April 5th. And we do have a few virtual chapter meetings for the remaining of the month, so if you have a chance, please check them out as well. We have been having SQL Server 2014 launch webinar series. So for the past sessions that you might have missed, you can go to the sqlpass.org /SS2014 launch to check if the session recordings are available. And there's actually an upcoming one for performance virtual chapters, so feel free to check that out too. And our past virtual chapters is actually growing now. We have quite a lot of them, so if you are interested, don't forget to join them as well. We always appreciate volunteers within PASS, so if you are free and would like to volunteer for the community, please do so. Please go to your PASS membership or PASS account and then go to the My Volunteering section to volunteer. And a very exciting conference coming up shortly in May 7th to 9th. So if you haven't registered yet, you can do that and use our discount code BAVC05, and you'll be able to enjoy the $150 off for that registration. If you'd like to stay involved, please go to sqlpass.org. We do have quite a lot of exciting news around PASS, especially with PASS Summit coming up and things like that as well. Now I'd like to welcome the star of today's session, Josh Fennessy, who will be talking about visual analytics with HDInsight and Power View. He's also going to be presenting at the Past BI conference on Master Data Management Case Study, MDS and DQS. So I'm sure you'll enjoy this session by Josh. Over to you, Josh.
Great, thanks, Julie.
I'm just going to change you as a presenter.
Okay.
All right. You should have control now.
Okay, yep, it's coming up. Thanks. Great. Well, welcome everybody to our virtual presentation today. It is in my time zone. It's 6 o'clock in the evening right now. So if it's evening for you, good evening, and if it's some other time, then good morning or good afternoon. So, my name is Josh Fennessy, and I hail from Grand Rapids, Michigan. Grand Rapids is the third largest city in Michigan, so if you know where Michigan is, Grand Rapids is somewhat of a major city, although it's not really major, but it's the third biggest city in Michigan. I am a business intelligence architect for Blue Granite. We're a Michigan-based BI consulting firm. We have been doing the business intelligence thing, since a little bit before SQL 2005 came out, and that's when I got involved in this space. So, I've been implementing these BI solutions for 7 or 8 years now, and we've been doing this for quite a long time. I've really enjoyed watching things change over the years, and it's been fun learning, and now is probably some of the period of greatest change that I've seen over the last 8 years. As we'll see in today's presentation, there's a lot of really great new and exciting technologies coming out. I hold a MCSE in BI, and as far as PASS goes, I run a chapter in Grand Rapids called West Michigan SQL, and then I also help out by being a regional mentor for the Midwest region in the United States. So definitely, Julie mentioned we're always looking for good volunteers, and absolutely there's a lot of rewards to being a volunteer, to giving back to the community. So please, if you have some time available, please do sign up to be a volunteer. So a little bit about what we're going to be talking about today in this session. As you saw from the title, there's lots of buzzwords in my title. Visual and analytic and HDInsight and Power View are all buzzwords. So this is kind of more about what we're really going to be talking about. So today's topic is going to be all about Hadoop and how we can use Hadoop with technologies that we currently know in the BI space, which are things like analysis services and Excel and reporting services. So how does Hadoop fit into all of that? So today what we're going to be talking about a little bit is just kind of some foundational knowledge about Hadoop. So if you haven't really had much experience or much exposure to it, we'll touch on it today, and we'll do a little discussion around what Hadoop is, and when we say unstructured data, what kind of does that mean, and whatnot. And we'll look at some specific details around HDInsight, and we'll talk about what the difference between Hadoop and HDInsight is. And then we'll also, if you've heard a term called Hive, we'll be taking kind of a deeper look into Hive and how that works. And then we're going to kind of finish today with combining the Hadoop space with that space we already know in the BI world, analysis services, and look at how the two kind of interact and how we as business intelligence implementers and developers and practitioners can access this data in Hadoop. So what I've kind of seen in my day-to-day is Hadoop is obviously gaining ground in the enterprise, and it's becoming more than just a fleeting piece of software. So I don't think that the traditional BI implementations are going to completely go away, but Hadoop is definitely something that we're going to have to be touching on. So it doesn't mean that everybody has to go off and learn Hadoop and be Hadoop experts to be successful in the Microsoft BI space, but definitely knowing how to interact with it and what some of the terms are and how to get at some of that data is going to be a big help as your career grows over the next few years, because this technology is not going to go away anytime soon. So Julie, just real quick, as we go through these different sections, if we have some questions come up, if we can maybe just address some of those before we move on to a section. Would that be okay?
Yeah, sure, no worries.
Cool. I'm totally cool with being interrupted, so if something, an important looking question comes up, please just let me know. Okay, so let's talk a little bit about Hadoop and what it is. Hadoop basically is a suite of applications that run on what's called the Hadoop distributed file system, and that's a file system, right? So Hadoop is primarily a distributed set of it's a distributed set of file servers that run in a cluster, and primarily that's the core of what Hadoop is. If all you had was HDFS, which is the file system, you could interact with those files in such a way to analyze data. Now, to make that analyzation simpler, there's been several different applications written that interact with HDFS. And we see some of those applications here in this view, and there are many more, of course, but this view we're looking at happens to be the applications that are included with HDInsight. So these are kind of where the focus of this presentation is. There's probably, maybe 8 more that don't come with HDInsight by default yet, and they all kind of perform different functions and have different uses. But this is kind of what it is. So when we say Hadoop, we're not talking about a single thing. Hadoop is really a collection of various bits of software that we can interact with this HDFS. And typically when you say Hadoop, the core of it is that HDFS. And we'll take a look into what that means and kind of a little bit how it works. But the actual architecture of kind of how it works is a little bit off topic for this presentation here. So just to kind of go through, so we're familiar with the applications that are included with HDInsight. So as we're talking, these terms make somewhat sense. Again, HDFS is something you'll see all the time when you're interacting with Hadoop, and it's a distributed file system. So we'll look at some hardware architecture here in a few minutes, and we'll see that when we copy a file into HDFS, that file is distributed amongst n nodes, and that allows for parallel or queries in parallel and redundant processing and high availability and disaster recovery and all these things that running things in a cluster provides for us. So that's what HDFS is. When you see that, it's really the file system. It's how we store files within Hadoop. Along with with the Hadoop file system is MapReduce, and these two pieces here kind of make up the core of what Hadoop is. And if all you had was HDFS and MapReduce, you could do all of your analysis with these two tools. And MapReduce is really, it's a programming model that's designed for working with large data sets. So it generally involves a two-step process. So the process of mapping, which is kind of analogous to the where clause in our SQL statement. So mapping is the process of going through a set of data and determining what data we want out of the complete set. And then the reduction process, or the reduce process, is if you have a query, for example, that's doing a sum and you're doing a group by, that sum and group by is kind of what the reduce process does. So it takes that data that we've identified and does some sort of a reduction on it, whether it's a sum or counting distinct or something. That's kind of what the MapReduce process is. In Hadoop, specifically, this is implemented in Java. So if you want to write what we call MapReduce code, what you're really writing is Java. So if you really want to get to the core of Hadoop and just interact with HDFS and MapReduce, you would better know Java. And if you don't know Java, you won't be able to get very far. And in order to make the Hadoop environment accessible to other people other than just Java developers, there's been lots of other applications created that sit on top of HDFS and MapReduce that help us interact with that. And one of those applications is called Pig. And I love the names of the applications within the Hadoop space because they're just great. So Pig is an application that is generally targeted towards string manipulation. So this would be used for textual data, or if we need to read line by line through a file. And for when we work with Pig, we actually use a language called Pig Latin, which is great because as a kid I was pretty proficient in Pig Latin. Unfortunately, that doesn't translate here because Pig Latin is actually a scripting language that bears no resemblance to the childhood language. But it's a very powerful language that allows us to manipulate files and implement lots of regular expressions and do lots of things with file manipulation here. So that's one of the applications that's inside or that sits on top of our HDFS and MapReduce layer. Another one is Hive. And if you're a SQL developer kind of starting out with Hadoop or HDInsight, this is kind of one of the places I recommend starting. It's where we're going to look today. And it's kind of referred to as the data warehouse infrastructure of Hadoop. And what it does is it allows us to create table metadata around a file, as we'll see here in a little bit. And then we can interact with that table using code that looks pretty much like T-SQL. It's not exactly T-SQL, but it looks very close, as we'll see. So this is a great way for SQL developers like us to jump in and start using Hadoop technologies. Scoop is another one. Again, great naming. And it is a tool that lets us bring data from a relational database into Hadoop and the other way around. So this is very much a data movement platform or application within Hadoop. So a lot of times you'll see Hive and Scoop being used together to bring data from a tool like SQL Server into HDFS and vice versa. And so this is where you can use that tool. One final tool, just again, so we know the terminology, is called Oozie, and this is kind of our workflow scheduler in this stack. So when you spin up an HDInsight cluster, as we're going to see here in a minute, these are the applications that you get included with that cluster. Some of the other applications that are included in Hadoop, whether you're implementing a Hortonworks cluster on Linux or on Windows or Cloudera, there's other applications you can get access to if you're kind of building your own on-premise cluster. But one of the benefits of doing HDInsight cluster, as we see, is very simplified cluster building and whatnot. So those are kind of brief, very brief overview of just some of the applications when we say Hadoop and when you hear words like Pig and Scoop, just so kind of we know a little bit about what those are.
Josh, we have a question here.
Yes.
So will Microsoft HD Insight ever support C# versus Java? Just curious, further fragmentation appears to be occurring in tools.
Yes. So the question, will HDInsight ever support C# over Java? The answer is yes, they already do. So if you want to write pure MapReduce code, it's written in Java. But with HDInsight specifically, you have the ability to write what's called streaming MapReduce code, which is very, very similar. There's some minute differences in the way that they're implemented, but that allows you, the streaming MapReduce code allows you to write that in C#. So if you need to write MapReduce, raw MapReduce for some reason, you can write that with C# using HDInsight. If you have an on-premise Hadoop cluster, that may or may not work depending on what you implement internally. But with HDInsight specifically, you can use C# for that with a streaming MapReduce. That being said, the kind of reason for the application layer on top there is hopefully we don't need to be writing all of our applications as pure MapReduce, because there's quite an inherent development cost there. But in some cases we do, so it's good to know that we have some options there. Thanks. That was a great question.
Okay, thank you.
Okay, so just, did you have another question, Julie? I'm sorry.
That's it for now.
Oh, good.
Thanks.
Okay, great. So just moving on from kind of the high-level software overview to kind of a little bit of how the hardware works. This is kind of a typical Hadoop cluster, and Hadoop was designed to be built using consumer hardware, commodity hardware. So when it was originally designed, it was we don't want to spend $1 million on all these servers. We want to just go out and just buy computers off the shelf and put them together and make them work quickly with each other. So when we're building Hadoop clusters, that's kind of what the target hardware is more consumer grade hardware, not your enterprise level server hardware. Because what you end up with in a Hadoop cluster is you have kind of a single head node whose job is to keep track of all the individual pieces of the cluster. It also accepts job inputs and processes jobs and returns the results of those jobs when they're complete. And we may have 100 data nodes or compute nodes, as they're called in HDInsight, that's processing all that data and storing the data in the HDFS file system. So typically this is kind of how it is. You have your single head node and lots of data nodes doing all this processing. And if you've ever worked with like a mainframe style environment, that's kind of how Hadoop is. You submit a job to it, and then you kind of sit and wait for that job to be completed and returned to you. It's not like SQL Server where we're at a query terminal and we hit F5 and we want that query to come back right away. Hadoop's very much a job submission and sit and wait sort of thing. So typically, a lot of times these jobs are kind of kick it off. You wait the 8 hours for it to do its processing, and you come back and consume the results of that processing. So it is a little bit different kind of architecture as far as how we work with it, but it's also used for a different purpose than a relational style SQL Server as well. We'll see HDInsight is pretty much like this hardware architecture-wise. There's some slight differences that we'll talk about in just a second, but for the most part, it's the same sort of thing. You get a head node, and you get several compute nodes that you can specify. So going along with Hadoop and HDFS and the hardware is MapReduce, and MapReduce is a pretty important concept to understand. Maybe not how to write all of it, but at least how it works, because all of those languages like Pig and Hive and whatnot and Scoop, they all kind of compile down into MapReduce. So when I write a Hive statement, like select star from table, it's actually taking that statement and compiling that into Java code, into Java MapReduce code for me. So I don't have to know how to write the Java to make that happen. All I have to do is write my Hive query. And so, just to kind of get an idea of how MapReduce really works, it's just a simple example that we can walk through quickly. So if we start with a very simple statement, like I would not like them here nor there, I would not like them anywhere. If we wanted to go through and write a MapReduce application to count the distinct words in this statement, which is, distinct word count is kind of like the hello world of Hadoop. So if we wanted to look at what that kind of looks like, the first thing that happens is you have some mappers that are created. And depending on the complexity of your data and the complexity of your job that you've submitted, whether it's a query or what is it, you might have one or more mappers created, and there could be hundreds of mappers created in some cases. But what the mappers kind of do is apply a key value pair system to your data. So in this simple case, we've had two mappers have been created for us, and they've simply applied for each word in the statement, it's applied the value 1 to it. So you can see here that our statement is broke out, and now we have all these key value pairs that have the value 1. Now if we want to count the distinct words in there, now that we have these words mapped, all we have to do is do a group by word and add up the values. And that's what the reducer is used for. So the reducer takes the results of that mapping and reduces it down based on the operation we need to use. So in this example, we can see the word not got reduced from 2 individual nots into 1 with a value of 2, which tells us that there's 2 instances of that word showing up in this statement here. So again, very, very simple example. But this is, if we want to do a hello world in MapReduce, this would be where we would start. It's kind of doing the distinct word count. And conceptually, this is kind of what's going on behind the scenes. So good news is if you're a casual user of HDInsight or a consumer of HDInsight, you probably don't need to know, exactly how to write MapReduce or exactly what it's doing behind the scenes, which is good because it gets fairly complex. But even if you're a Hive developer, you really probably don't need to know how to write your own MapReduce. But it is helpful to at least know, what that process means. So that's just a quick overview of that. So that's kind of our very, very quick and brief Hadoop overview. So Julie, are there any other questions before we kind of move forward with talking about HDInsight?
Nope, no questions so far.
Great. Great. So we've talked about Hadoop. Now let's talk about HDInsight. So how is HDInsight different from Hadoop? And the answer is it's really not different from Hadoop because HDInsight is Hadoop. What it is, it's a partnership between Microsoft and Hortonworks, and it's a cloud implementation of Hortonworks Apache Hadoop for Windows product. So Hortonworks has historically, has had Apache Hadoop that is run on Linux clusters, and in the last couple of years, they've created a version of that runs on Windows. So now you can run Apache Hadoop on a Windows cluster, and if you wanted to build that on premise, you could do that. You could go download Apache Hadoop from Hortonworks and implement a Windows-based on-premise Hadoop cluster. That process is not really trivial. I mean, it's fairly complex to set up a Windows Hadoop cluster and fairly complex to set up a Linux Hadoop cluster if you know Linux. As we know, Microsoft's pretty all in with the cloud right now. So what they've been working on with Hortonworks is kind of partnering to develop this cloud-based solution where we can quickly and easily deploy Hadoop clusters in the cloud. And this is what we end up with. So we kind of talked about those applications that are available, and when you spin up an HDInsight cluster, this is kind of what you get. And this data is kind of always out of date because being Azure, it's always changing. But at the time that this slide was created, which was only a few weeks ago, this was kind of the versions of everything. And even since then, there's been updates to HDInsight, so there's newer versions of things out there than what's even listed here. But you get the Hadoop Foundation, you get Hive, you get Pig, Scoop, Oozie, and in a couple of other applications that Hive uses as well to handle things. So that's really what HDInsight is. It's a cloud-based implementation of Hadoop that is really pretty easy to set up. As far as the hardware architecture goes for HDInsight, it's primarily the same as an on-premise cluster. You still have your name node and you have your data nodes or your compute nodes, but the big main difference is that it uses Azure storage heavily. So when you spin up a Hadoop or an HDInsight cluster, you must specify your Azure storage account or create a new one because there's going to be lots of configuration settings that are put onto that Azure storage, And it's also, when you're using HDInsight, all of your data is going to be stored in Azure storage as well, as opposed to being stored natively in HDFS, which is a pretty big difference between an on-premise installation and HDInsight. So, it's going to want to take advantage of that Azure storage redundancy and speed that's set up there to store all that information. So, what does that mean for us as consumers or developers? Primarily as developers, it just means that we upload our files to a different place. And so, we probably don't use the HDFS command to upload the file. We do a command we'll see in a second with either PowerShell or use a tool to upload files. As a consumer, same sort of thing. We just specify that our files are coming from Azure storage as opposed to coming from HDFS. So that's kind of the main differences there between HDInsight and the standard on-premise Hadoop installation. How we get HDInsight, if you've never used Windows Azure before, you generally interact with Azure using the portal, the Azure Management Portal. We'll see that in just a second here. There's also a lot of PowerShell integration with Azure, so if you're finding yourself creating these HDInsight clusters and tearing them down quite often, you can kind of script that with PowerShell and make that into a very easy to execute job that just kind of creates a cluster and submits a job and tears it down. But what I kind of wanted to show today is just kind of how easy it is to set up an HDInsight cluster. And so if you've never seen the Windows Azure portal, that's kind of what we're looking at here. And you can see along this left side here I have lots of options for creating different types of objects, and one of them is HDInsight. And so I get an option here that says I have no HDInsight clusters, create one to get started. So I can create a cluster here, and I get an option of, do I want to use a quick create or a custom create? And making pretty sense. I mean, the quick create just uses all the default options for that. But let's go ahead and take a look at what the cluster or the custom create looks like. So as far as setting this up, it's really just as easy as specifying a cluster name, specifying how many data nodes you want to have. So I'll just say I just want to have one data node. When you do the custom create, you can specify which HDInsight version you want. Just so you know, this version 3.0 is pretty new. I mean, it's as of the last couple of days new, and it is actually running Apache Hadoop 2.0 as opposed to 1.2. So this is the latest and greatest version of HDInsight that's out there, which is a couple of versions behind, a couple of subversions behind what you can do with on-premise, but it's still using basically the latest Hadoop code, and just kind of specify what region I want things to be in. You have to configure kind of the username that accesses the cluster by default, and so we can specify that. Actually, you've got to specify it with the right number of characters. And this is where we're specifying the storage account. Like I said, when you create a Hadoop cluster, you have to use a Windows Azure storage account. And if you don't have one already, you can create a new storage account. If you already have a storage account created that you want to reuse for this process, you can go ahead and choose that. And I have one that I use for these. And you can specify additional storage accounts that the cluster is linked to if you'd like. And then when I click the check mark, that's pretty much it. It's creating my Hadoop cluster right now. And if we were going to sit and wait for this, we'd wait probably 10 or 15 minutes. And when it's done, I have a running Hadoop cluster that I can start interacting with, which is pretty great. I mean, the first time I was learning this technology and said, well, I'm going to go build my own Windows Hadoop cluster, I mean, it was a couple of weeks before I really got everything working right. And I don't even know if I had everything working right because I didn't know everything about it. So, but before I kind of had everything going, it took quite a while. And to be able to do this in 10 minutes and do some testing or even execute some real production jobs is a pretty great thing. So a little bit about pricing, and you may have seen some pricing information on that slide, and there's a little asterisk statement there that says, this pricing is as of January 1st, which means it's not valid anymore because Azure pricing is kind of always a moving target, and depending on what level of customer you are with Windows Azure, your prices are going to be different. So, but generally, how it's priced is the Hadoop cluster itself is made up of several virtual machines, and so you pay for those virtual machines as they're running. And with Azure, you pay for everything by the hour. So every hour those virtual machines are running, you're paying for them. Now, with a standard Azure virtual machine, you can shut it down from within Windows, which means you still pay for it, but you can also shut it down from the management portal, and you can deallocate it, which means it's deallocated from its host hardware, and that means that the configuration of that that virtual machine is saved, but it's not allocated to any hardware right now. So it means that you're not paying for that virtual machine right now. With HDInsight, even though it is made up of virtual machines, it's considered to be a cloud, a compute service. So there is no notion of deallocation. So if you start up an HDInsight cluster, you're basically paying for it every hour that it exists. And if your needs for your Hadoop cluster require, say you have a monthly processing job that consumes a bunch of data and spits out a bunch of output that you then spend the rest of the month analyzing that output. So you only need that Hadoop cluster running for 2 days. You can, out here with HDInsight, you can spin up that cluster, execute your job, and then delete it. And then deleting it will make it that obviously you're not paying for it anymore. And since these HDInsight clusters are typically things that we spin up, we submit jobs to, and use the output from them, that kind of works okay, because generally we don't have to do custom configuration of this machine at all. We just access it through a job submission program using PowerShell or any couple of other tools like .NET that we could use. And so we submit our job and we're done. Now that cluster can be gotten rid of because we don't need it until the next time we need to submit a job. So kind of the important thing for us as developers and practitioners is that, in my example, I have an MSDN account that gives me a certain number of Azure dollars per month, and those Azure dollars per month are not enough to run an HDInsight cluster all month long, by the hour. So just kind of keep that in mind that, if you want to play with this technology, that make sure you're kind of deleting that cluster out. Otherwise, it could eat up your money fairly quickly. So there is another option, though, if you want to just get in and do some development in this or some exploration in this technology, and that's called the HDInsight emulator. And this is a great tool that allows us to kind of create a local single node HDInsight environment that we can just use for development and testing. And it is completely run outside of Azure. It runs on a virtual machine, or you can even run it, on Windows 8 if you really wanted to. I'd probably recommend running it on a virtual machine. But you can go to I've got a little shortcut URL here. These slides will be made available, so don't feel free. You don't have to write all this down. But you can go here and start the process of installing the emulator. And it's really pretty easy. And we're going to actually use the emulator for most of the rest of this this presentation here. So how you get the emulator, if you've never used it, is this web platform installer. And this is a great software deployment tool that Microsoft uses that we can just kind of say that if I wanted to see HDInsight, I can search for HDInsight and see out here that, hey, here's this Microsoft HDInsight emulator for Azure, and I click install and I wait 45 minutes or so for everything to download and install. And when I come back, I've got a single node HDInsight cluster running on my local hardware, and it works pretty well. And when it's done, it's ready to go and ready to accept jobs. So if you're looking for a way to kind of get in and start doing some development and some testing on this technology, and you don't have an Azure account, or you don't want to use up all of your Azure dollars running it completely in the cloud, this can be a great way to get started with it. You probably need a few other things to go along with it. If you've ever looked at Azure before, you probably have learned fairly quickly that interacting with Azure using PowerShell is very common. And if you haven't started learning PowerShell yet, you kind of be forced to when you're dealing with Windows Azure. You can do probably about 60% of the things you need to do within the portal, but you're eventually, no matter what part of Azure you're using, you're probably going to run into a case where you need to use PowerShell because that specific functionality may not be implemented in the portal yet. So, definitely we'll use Windows Azure PowerShell, and that's a kind of a set of modules, of add-ins for PowerShell that you can use. For development and testing, Azure Storage Explorer can be pretty helpful. There's actually many different tools you can use to browse the Azure storage account as if it were like a Windows file system. This just happens to be one that I use because it's free and it works fairly well. Of course, Visual Studio, because we'll probably at some point want to interact with our cluster using .NET, whether it's for streaming MapReduce or for job submission or something, we'll probably need those tools. And then also for development specifically, it can be helpful to run an Azure storage emulator, and we'll see some of that in a few minutes here when we start doing our Hive demo. So that is a brief look at HDInsight. Julie, do we have any questions out there?
No, we don't right now.
No questions.
No
Good.
questions.
Okay. So the next piece we kind of want to go into, and this is kind of getting away from what is Hadoop and what is HDInsight. This is where we're specifically talking about, as a BI professional, how and why do I care about this? And so this next whole section is going to be talking about how we interact with data with Hadoop and HDInsight, and what does it mean for tools that I know already, like analysis services and SQL Server and Excel. And so, for me, the starting point for me was Hive. And honestly, it's because Hive is probably the most familiar thing in the entire environment to SQL Server. So it was a very good point for me to start. So that's what we're going to look at, and we'll go through kind of what Hive is and see a bunch of examples and play with some real data, and then move into how it interacts with analysis services. So as I kind of said earlier, Hive is called the data warehouse engine of Hadoop, and really what it allows us to do is it's a metadata engine that allows us to write table metadata around files. And so it's expecting our files are structured, basically. I mean, I know that we love to say that Hadoop is unstructured data, but it's kind of a misnomer, because if our data has absolutely no structure, it's kind of hard to analyze. So with Hive, it's kind of expecting that our files are very well structured. They're either comma separated, tab separated. They're what we call rectangular data. So that data, I could import that data in Excel, and Excel would be able to consume it just fine. And so that's kind of what Hive is looking for. And we can do all sorts of things in Hive that are similar to the ways we do with SQL Server. We have tables, so we can create tables of data where I can say select star from a table. I can partition tables, so I can kind of create some parallelism there. I can create indexes and views on things. So if I have a specific query and I want to create some index, I can do that. If I have an aggregation query that I want to reuse amongst other places, I can use a view for that. It also has user-defined functions. Those are a little bit different than what SQL says user-defined functions. So as you know, in SQL, user-defined function is kind of a T-SQL statement that we write that executes. In Hive, a user-defined function is like a Java class that gets executed. So it's kind of like CLR for SQL, but they're called UDFs in Hive. And so those are going to be written in Java. As far as I know, there's no C# equivalent there. The Hive team is separate from the Apache Hadoop team. These are separate teams to work with, but so UDFs are going to be Java based. And as far as what happens, when we execute, when we execute that, what's going on is that the Hive code that we'll write, that we'll see in just a second, kind of gets translated into MapReduce. And as we go through some of our examples, we'll get to see what maps and what reduces are being created out of that. So just some real quick examples of what Hive code looks like. And this should look very familiar to a lot of us. So, there's statements like show tables, there's describe table, there's select, a list of columns from a table. Very, very similar things to T-SQL that we use. One note to keep in mind is, unlike SQL Server, Hive is very particular about semicolons. So if you are not including semicolons in your statements will not execute correctly. So you need to kind of be very aware of semicolons in your Hive code. Another very easy example to see, or quick example, is the create table statement. We'll see one of these in quite a bit more detail, but looks pretty similar to how we create a table in SQL Server. We have a create table, give it a name, give it a list of columns, a list of data types. There's some other information in that statement that we'll talk about. But basically, if I'm a SQL developer, I would feel pretty comfortable stepping into Hive and at least getting my way around. So, let's go ahead and let's take a look at some of that. So, to kind of set the stage here, I'm working on an HD Insight emulator machine. So, while I could absolutely transport all of this code to an HD Insight environment, and when you're presenting, you don't always want to have to rely on good internet connections, because you never know. So I've got this this wonderful little HD Insight emulator that I'm using, and everything runs exactly the same way. But I just want to walk through a couple of things here. So one thing that I'm doing is I am running the HD Insight storage emulator, which is a great little development tool that lets you simulate the use of Azure storage blobs on a single machine. So you can see I'm running the Azure Storage Blob engine here, and that allows me to connect to using tools like Azure Storage Explorer, which allows me to browse storage blobs as if they were file systems. I can connect to this special storage account called Dev Storage, and I can go out there and look and see kind of what data is out there and browse it and look at that data. So these are files that are weather data that I have stored in my local Azure Storage Emulator account here, and I can browse them with this Azure Storage Explorer tool. And this tool here is a free tool you can download, and it's out on Codeplex. And if you're doing development, it's pretty helpful. You can do things like upload files to your storage account. You can download files. You can open them and view them, and kind of start to see how these tools interact. And we'll see some more examples of this as we go forward here. So just want to kind of set the stage of what I'm running on this machine. As you'll see pretty quickly, Hadoop, if you're interacting with the Hadoop node specifically, it's very command line based. Right now, at least, there was, in the preview mode of HD Insight, there was a job submission web page, and hopefully we'll see that back at some point. But for right now, it's very command line based. And also lots of PowerShell interactions, so we could submit these jobs with PowerShell. So we'll do a lot of command line stuff here today, and then we'll also see how we can use Excel to get at some of the data as well. So just to get a quick look at what this data actually is, and I have this crime statistics from 2006 through 2008, and they're just comma-separated files. And if I just take a look, these are very basic comma-separated files that we would get from anywhere, right? So very simple pieces of information, and this is what it includes. Is just this comma-separated data here. So very simple pieces of data, and that's what we're going to be working with Hive. So the whole point of this is we need to do several things. So first, we need to get these files onto our Azure storage account so that Hadoop or HD Insight can see them. And then once they're on a storage account somewhere, then we need to define using Hive what do the tables look like. Once we've created those tables and how those tables are aligned as far as the columns and data types, we can start writing statements to query that data. So that's what we're going to walk through here over the next few minutes and take a look. So the first thing we want to look at doing is how do we upload multiple files to our Azure storage account. And while you could use a tool like Azure Storage Explorer and click the upload button and browse, typically we want to kind of do this where it's repeatable. So PowerShell is a powerful tool that we can use to do this. So if we want to walk through this code a little bit, we can see the first couple of lines. The first line here is just kind of setting up the connection string to my Azure storage account is all the first line is doing. Within Azure Storage, you have the ideas of containers, and so you have a container, and a container holds blobs. So there's not really an idea of files in Azure Storage. It's all blobs that are sorted in different containers. So for this example, you can see through my connection string, I'm using my development storage account, and I want to have a container called crime is the container I want to use. So I can run a simple PowerShell command called new Azure storage container that will create that container called crime. And if I wanted to make sure that that container didn't exist first, I could run a little check to see does that container exist, and if not, create it. Once I've created that container, I kind of need to set for the rest of the commands. I need to set what my context, that container context is. That's what this command does here. Is just says basically it's saying use this container called crime. And then these 3 lines after here are simply just uploading files. So this command set Azure storage blob content, it's really just saying I want to upload this file to my Azure storage. And this is the file that on my source system where it comes from, and this is this blob parameter here with this data slash, that's where I want that file to end up. So if I run this code here, of course we're going to see cannot find container crime because I've got something highlighted. If we run this code, we'll see, it'll start uploading these files, and you'll see the green bar kind of blink and go away, and that's because it's uploading them locally. But so what we've done here is created a new container called crime and uploaded 3 files. If I go back to my my Azure Storage Explorer here, you can now see that I do have a container called crime, and when I click on it, there's 3 files in that storage. So now I have exactly what I said I wanted, and I'd even put them in this, it named the blobs data slash 2006 US yearly and so on. So while Azure Storage itself doesn't really have a notion of folders, if you name your blobs with slashes like this, tools like Hive can see those as folders. So in Hive I can say, all of my crime data exists in this directory. Over here it lives in data slash, and it'll pull everything from there for Hive. So that can be fairly important as we move forward here. So now that we have our files uploaded to our storage account, now we can start to use HDInsight to interact with those files. So the first thing I said we need to do is after we upload the file, we need to define the structure of the file in Hive. So that is done with the create table statement. Let me get into the right directory here. Oops. Remember what the right directory is, all right. It's source files. So the first file that we can look at is just this create table statement. So we'll kind of walk through, because while this does look somewhat like a SQL Server create table statement, there are some differences here. So this part, as far as the create table and the name of it and the columns, that all looks pretty much exactly the same. This word external is kind of new, and then also all of this business at the bottom here is kind of new as well. So first, let's start with the word external. So as you know, in SQL Server, if we were to create a table and then spend a lot of our precious time populating data in that table, if someone were to go along and say drop table, that table and all of its data would be gone, right? And the same thing goes with Hive. If I say create table and give it a name and spend all my time populating that data, and someone comes along and drops that table, that data that was inside the table is gone, unless I use this external keyword, in which case when I drop the table, all it drops is the metadata describing what the columns of the table are, but it leaves all of the files, all of the data alone. So when you're in Hive, if you want your data to remain around after the table is gone, you can use the external keyword to do that. Now, in Hive, as we're thinking about this, even though this looks like SQL code, remember it's not SQL code, so we're not actually creating, pages that are storing data in pages here. Our data is stored as blobs in Azure Storage. We're just creating metadata around that blob to say that this is what the columns of that blob are. So when we are populating data in here, we're not really inserting rows to anything. We're kind of merging metadata and actual blob content into one thing. So what this is telling us down here at this bottom, at these bottom two lines, it says row format delimited fields terminated by comma. And what that's basically saying is this is comma separated fields. So every field is terminated by a comma. And then I want to store it as a text file because that's how my data is stored in there. And then I have my location. And you'll see that my location is this WASB, and that's Windows Azure Storage Blobs. And then the crime here is my container name, so crime at storage emulator, and that's telling me that I'm using my dev storage. If you're using actual HDInsight, you would use, it would give you the URL that you need to use, and it's at, I think it's at like storage account, windows.storageaccount.com or something similar to that, but it's in there. And then this is the path that I want to store my data from my table in. So, right now I've uploaded my files to the data directory, but I want to store them in the /hive/ext crime directory. So that's kind of the first file that we're going to look at. And if I were to execute this file, what this will do is the Hive command is the Hive executable, and the /f means I want you to execute a file in Hive. So I can store a Hive command as an HQL file and then execute it directly from the command line. So I basically just said execute a Hive statement, and this file contains that Hive statement. So I've executed that create table statement now in Hive. So if I were to log into my Hive console directly and say something like show tables, as we saw as one of the sample, it's now going to list all of the tables that exist within my environment. And the OK is not a table. That's just an acknowledgement that I received your command. The only table in my environment right now is ext crime US. So that's the table that I have. Okay. Again, exit. It gets you out of the Hive console, and you do need to have a semicolon. Otherwise, it will never exit. It will just sit there forever waiting for your next input. Now, so we've created this table, this Hive table, that has a specific structure, but it doesn't have any data because all we did was create the metadata. We never merged it with our data that's in our storage blob. So this next command here actually goes through and loads the data that is in our Azure storage into that metadata that we created. And it's a fairly simple statement that just says load data in path. And so this path is the path to where our data lives. And so it's our crime container on our storage emulator, and we want to load everything that's below data. So if we remember correctly, the 3 files I uploaded were all data / and then a file name, right? So this command will pick up everything below data, which is exactly is what I want it to do based on how I've created this information here. And then I just say overwrite into table and then give it a table name. Now what's going to happen here is, remember, this isn't SQL, so we're not going to be inserting rows into a table. What we're actually going to be doing is kind of moving files around. And so we're going to move files from the data directory into the directory where our table exists, which was crime which was Hive/ext crime. So if I execute this command here, which it'll just take a second, we can see that in just a little bit here it'll be complete because it's actually moving those files right now where it says loading data. And so that took about 7 seconds. And if I take a look at my storage emulator right now and I click refresh, we're going to see these files move from data to the Hive directory. And so once I click refresh and go back into my container, now we can see that I have these other directories have been created for me by the Hive metadata engine, and it's moved these tables into the Hive directory here. So now what that kind of means is that I have data, or I have created tables, and I have data in those tables. So now that I have data in those tables, I should be able to look at that data with a select statement. And if you've ever written a select statement before, it should look pretty familiar. So our statement is select star from ext crime US and limit 100. That's kind of Hive's version of select top 100 star. And so I can execute this command here, and it will go off and return the top 100 rows from my table. And there you can see it took a couple seconds, and here are the tail end of those top 100 rows. Okay, so as of right now, everything has been pretty straightforward. And just to kind of recap what we've looked at so far, we've seen this show tables command that lists the tables we have. If we can also use this describe table and pass it a table name, and this will actually, I think I have to. It's just describe, I'm sorry. But the describe command kind of lists out all of the fields and what the data types are in that table that we specified. So here of the table ext crime US, here are the fields that are included with that, and those are the data types. So if you ever need to get in there and look at what's going on in your environment, what's in your table, you can see it there. Kind of the next example we want to see, just so we can kind of show that this is fairly comparable to SQL Server as far as what we can do with it as SQL developers, is create a view. So as you know, a view is kind of like a pre-written select statement that probably does some aggregation or some joining, and it allows for our users to kind of reuse that select statement without having to write it over and over. So for this example, I am just creating a view that does a group by, and so I'm going to do sum of all of the different types of crime, and I'm going to group it by state and year, and I'm going to create this view with this extraordinarily long name called ext crime US aggregated by state. And the syntax here is exactly like SQL Server. It's create view as your select statement, and then that's it. And one of the kind of differences with Hive and SQL Server is you can actually use the order by clause in a view. Don't know if you'd always want to be doing that all the time, but you can do that within Hive. So if I create this view out here now, this command will go ahead and it'll run. Should run fairly quickly. And now if I go back and I look at that list of tables that I have, we're going to see another table out there, and it's going to be our view. So now if I say show the tables in here, here's the base table, and then here's this view that's sitting out there. And you'll notice this doesn't really tell us if it's a view or a table, because it just lists it as a table. But now that it's there, now we can interact with it. And this command that we're going to run, here. Oh, sorry. If I say that I want some of this data from this view, ext crime US aggregated by state. I'm going to regret making that so long now. What we're going to happen here is you're going to see total map reduce jobs equals 2, and it's going to launch. So this is where we're going to start seeing some of that map reduce happen. So we wrote a simple set, a SQL statement basically, or an HQL statement, and it determined that based on that statement and based on the data that's happening, that it needs 2 map reduce jobs. It's going to execute 1 map reduce job. When that one's complete, it's going to take that data and then do another reduction on it. And you can see here that this takes a little bit of time, because this isn't SQL. This isn't just returning rows from a table. This is actually reading through multiple files on a file system, and line by line reading through things and tabulating and doing a whole bunch of things to it. So while this example we're looking at is very, very simple, if you can imagine doing this over thousands of files and terabytes of information, this can be a pretty powerful process that we can do here. And so when this process is all complete, what it's going to spit out to us is going to spit out the result of that select statement. And it's going to say, here's the tabulation of all of that data in all 3 of those files here are the combined sums of that data. So that's kind of just a quick example of how Hive actually translates to MapReduce. So that is just a real quick, I know it's very brief, but a look at Hive. I'd like to just take a second to ask Julie if there's any questions here, and then we'll kind of continue on with tying this into the BI stack a little bit.
Okay, sure. There's no question, and just a reminder, it's already an hour, so
yep.
I'll let you go on because this session is recorded anyway. So
okay.
If anyone,
right.
any of the attendees want to leave, that's fine. We
okay.
can.
I was thinking we had an hour and 15. I'm sorry about that.
Okay.
I thought we had an hour and 15. So I've got 15 minutes left, and then we're wrapped up. So
that's okay. No worries.
If you can, yep, stick with me for a little bit if you want to kind of see how this is tied to SQL Server. So. All this HD Insight stuff is great, and if you wanted to just sit in the command line and write commands and look at data all day, great. But really what we want to do with this environment is we want to be able to take this data and bring it into some sort of analytic engine. And what better analytic engine than analysis services for us to use? So how do we get this data that is not stored in any sort of relational format? How do we get that into analysis services? Well, there's of course, we can output all of this data to a file and then use integration services to read that file and put it into SQL Server and use analysis services that way. But that's a lot of extra work, and that's kind of the whole point of doing this HD Insight thing is we don't want to create all this unnecessary ETL that in the past we've kind of been forced to do. So while we do have commands like insert overwrite directory, which means take the results of this query and dump the results to a file out on a directory somewhere, it would be a lot better if I could just use like sort of an ODBC driver or something to connect to Hive directly. So there's an ODBC driver available that I can go and download, and it kind of lets me connect either SQL Server directly to Hive through a link server or directly to Excel, and it works primarily like any other ODBC driver that you've seen. So you download the driver for it. You configure your system DSNs, both 32 and 64-bit DSNs, and you're off and running with it. So let's go ahead and let's take a look at what this looks like. So I'm going to switch servers here to another machine that's running in the same environment, and this has the ODBC driver configured on it. And you can see here that I have this HTTP ODBC driver set up. And just a couple of quick things to point out here. That's the host name of your HTTP, of your name node of your Hadoop cluster. The port for Hive is going to be 10,001. All of these are default, so you want to use the default database. Your Hive server type is going to be Hive server 2. This mechanism, if you're using the emulator, you want to choose emulator. If you're using Azure HD Insight, you want to use HD Insight. This HTTP path is very important. It is /servlets/thrift/hs. That's not very easy to find, and it's not well documented, so that took me a little bit to find that piece. But once I found it in a forum somewhere, and you hit test, it all works and it's connected. So this is telling me that the ODBC driver is successfully connected to my Hive cluster. So if I open up a tool like SQL Server Data Tools and say I want to look at creating a tabular analysis services tabular model to connect to my HD Insight cluster and bring in some data, it's very simple. I just like any other tabular model, I say I want to get data from a data source, and I want to use an ODBC driver to do that with. And I can just build this driver. So my provider is going to be the OLADB driver for ODBC. My data source name is going to be the one that I just created. And I can test the connection, and it works. And when I say next, I just use a service account for now. And I just want to select from a list of tables. And I'll see the tables that are created out in my the Hive system we were just working with. So I can import all of this crime data as the table ext crime US, and when I say finish, tabular mode analysis services goes out and it populates all of my table. It imported 25,000 rows, which happens to be exactly how many are in all of the files that I created. And here are my all of my files. So, if we wanted to just do some quick analysis of this and just say, how much arson is happening, I can say create just a really quick DAX formula that just says total arson equals the sum of arson, and show that. Now I can browse this, this model in Excel. And well, I don't have Excel on here, but I thought I did. But I can, as we can see now, we have this tabular model built. We can pretty easily hit this with Excel or Power View and kind of do whatever we need to do. So I can open up Management Studio, and we can take a look at what this looks like browsing through it, and it's going to look surprisingly like any other analysis services database that we work with. And so, if I browse this data here, I can see here's my measures, here's my total arson, and I can slice that by state and by year, and say, here are my totals by state, by year of all arsons. And so, once I have this data in analysis services, I can start using it against any of the standard analysis tools that I use every day as BI developer. So reporting services, Excel, Power View, whatever we need to look at it with. And it's very easy to get to if we're using Hive. So that's kind of it. So any final questions, thoughts?
We don't have any questions right now.
Okay.
So yeah, so if anyone has any questions, please feel free to submit your questions on the questions pane. And yeah, or otherwise, if you want to email us, maybe. Do you have a contact information, Josh, so people can go to you?
I think I do. I do have a set of links here that Julie, I'll send you all of the slide deck and the samples and the scripts, and that'll have a bunch of links for getting started with things. And yeah. I do have a couple contacts, so you can connect with me on LinkedIn here, and you can email me there, and I'll make sure Julie has this slide deck so she can post it and
yeah.
And have
thank
all
you so much for that. And this session is being recorded, and it will be uploaded on YouTube probably in about a week time. So yeah, and there'll be Josh's contact details if you want to reach him to ask more questions.
Yeah, absolutely.
That was a great presentation, Josh. I felt like I learned quite a bit from your session today, especially on just the basic fundamental part of the of HDInsight. And thank you so much for the session. It was really, really good.
Great, thank you. Appreciate that.
So I think we don't have any questions, so we might just end it now.
Okay.
I'll just stop the recording.